This is numbers 18 and 19 on your study guide. Both of these are proofs. In the first one, it says that we've been told that RSTU is a parallelogram, and then we are to prove that SRU is a congruent triangle to UTS. I'm going to go ahead and set this up. Recognize that there is more than one way you can actually do this proof. I'm just going to show you one, but then I'll talk you through two others. Alright, so number one, we know that RSTU is a parallelogram, and that is going to be given. And then number two, if you know it's a parallelogram, then we know the opposite sides are going to be congruent. In other words, SR is going to be congruent to TU, and ST is going to be congruent to RU, and the reason is going to be that we have the theorem that says opposite sides of a parallelogram are congruent. Now, we also have this third side right here, the SU is congruent to itself because of the reflexive property. So SU is congruent to SU by the reflexive property. And so, now that we have that, we have now proven we have side, side, side here, so we can now say that triangle SRU is congruent to triangle UTS. The reason is by the side, side, side postulate, which says that if our three corresponding sides are congruent to the three corresponding sides, then the two triangles are congruent. Also, guys, if you had preferred, since you knew that this was a parallelogram, you also could have gone for stating that these two sides were congruent using the reflexive property here. You could have said this was congruent, and then you could have used that these two angles here were congruent because they are alternate interior angles, and so you could use SAS, and the same with doing this one and this one with these angles, where you could have done SAS as well. So multiple ways that you could actually prove this. Number 19. It says, show that this is a parallelogram when A is 4 and B is 5. So what I'm going to do is I'm going to go ahead and plug it in. I'm going to do a very informal proof here. So I'm going to do 7 times my A, which is 4, minus 6, which gives me 28 minus 6, which is 22. And we're going to do 5 times the A, and then plus 2, so that's going to be 20 plus 2 is 22. So if you'll notice that these two, this diagonal is bisected because that's congruent. Now let's check the other one. We have B plus 5, so we're going to do B plus 5. So 5 plus 5 is 10. And then also this one here is 2B. So 2 times B, which was 5, is 10. So again, these two sides here are also equal to each other. So these two, or we can say MJKL, is a parallelogram because the diagonals are bisected, which we have a theorem that talks about if the diagonals are bisected, then the shape is going to be a parallelogram.